Okay, in this problem, it says glutaraldehyde is a germicidal agent used to sanitize surgical equipment, and that cannot be autoclaved. So, we need to propose a mechanism to get this. So, this is glutaraldehyde. Let's see how this can happen. First thing that I want you to see is that here I have a carbon and another carbon. Both of them are hemiacetals. So hemiacetals are intermediate in the formation of acetals, and they have OH, OR. Acetals will have OR, OR. So now I know that in this also, when you have a carbonyl compound, you can form an hemiacetal by doing an attack with an alcohol. And okay, say acidic conditions also. All right, so let's do that. First, another thing that is important is that aldehydes, for example, say that I have formaldehyde. Formaldehyde can form very easily, well, it exists mostly in water as a hydrate. And hydration reaction, that is your hydrate, can be acid or base catalyzed. So we can have this or this. So I'm going to propose everything in acidic condition because here I have acidic conditions. So I'm going to say use one of the carbonyl groups and make a hydrate. And for the mechanism of the hydrate formation under acidic conditions, we're going to form this first, and then we're going to have the attack by water. Your nucleophile is water, so you're going to do a nucleophilic attack over here. And now you form initially, say, OH, and now you're going to have an oxygen with, say, an extra proton, and here HH. And then water is going to remove that H here. And you're going to have the hydrate. So that is the hydrate formation. And here, that's an aldehyde. So aldehydes are very reactive in more than the ketones. And so I'm forming the hydrate over here. And next, the other thing that we want to see is that we here, the hemiacetal is cyclic for both. So meaning that the OH that I'm using to attack on the carbonyl group here is coming from the same molecule. So I'm going to be using one of these to do a nucleophilic attack. And see, another thing that I'm going to be doing is I'm going to do a proton transfer first, since I am under acidic conditions. So the proton transfer step, if we can do a proton transfer step here so that you see what is that we're doing. Under acidic condition, we will have hydronium ion, and so the lone pairs here are acting as base, and you're getting a proton. So this is how you get the that protonated. So once I have that, we're going to have the nucleophilic attack, an internal attack. And this oxygen is going to be this oxygen. Let's make it bold. And now, you know what? I am going to be drawing this in another color so that we keep track. This is this guy. Same molecule, only that I decided to draw that oxygen in a different color. And now we're going to be doing intramolecular nucleophilic attack. So we know that when this is protonated, it makes that carbon more electrophilic. So I'm going to do that internal attack. Now let's count how many atoms we're going to be forming a cyclic. To verify what we're doing, we're counting one oxygen, and then it is attached to this. So 1, 2, 3, 4, 5, and 6. And that actually, by the way, was an H. So we have a 6 memory. So perfect. This is what we wanted. So now I'm going to be drawing, this is that oxygen. being consistent with my color coding, I'm going to be doing that. And also this is going to have an extra H, and the rest I'm going to be drawing in blue as I have here. So I'm going to be doing 1, 2, 3, 4, 5, and 6. And the carbon here had an H and an OH. So I don't need to draw the H, but I do need to draw the OH. So this is this carbon. Let's do another purple circle. So this one, let's erase all of this. Just want to keep you guys keeping track of what is the atom that I'm using to do the circle. So that's that. And I have an OH. As you can see here, I didn't draw the hydrogen. So next is 1, 2, 3, and 4. 1, 2, 3, and 4. And at the carbon, I will have also an OH. An H that I'm not drawing. So I am omitting this H and the other H. And this is your product. Only step that we're missing here is removing the H at that oxygen. And this is done. Your base here under acidic condition is going to be water. So I'm going to be removing that. And in doing so, I'll get my molecule. So this is the reaction of glutaraldehyde under acidic condition to form a cyclic hemiacetal. Hemiacetal here and hemiacetal here.